Hello everyone. Let us continue from where we have stopped in the last video. In this particular video, we are going to have a look at the last 2 points of the topic called as strings. The first one is we are going to have a look at what is called as arithmetic operations on characters, followed by couple of string handling or so-called string library functions. Now coming to the arithmetic operators on characters, we can also manipulate the characters as we manipulate the numbers in C language. Whenever the system encounters the character data, it is automatically converted into an integer value by the system. Right? Now, so far we have done arithmetic operations on numbers. Let us see, right, how basically the arithmetic operations in terms of addition and subtraction can be carried out on characters. Let us have an example. I have a declaration statement called as char ch is equal to a, right? Now, since the initialization part of this variable ch is a, I have to enclose this in a pair of opening and closing single quote, right? Now, that is the syntax of character initialization. Now, the next printf will print the value of variable ch, which is nothing but capital A, right? Now, the reason why it prints capital A is because in this printf, I am making use of this format specification called as percentage %C. Now, the what I'm trying to do is I'm trying to make use of format specification percentage %D. And hence, what happens is this format specification percentage %D will print the ASCII value of capital A, right? And you all know the ASCII value of capital A is nothing but 65. And since 65 is an integer quantity, I am making use of the format specification called as percentage %D, right? Now, this is how I land up printing the ASCII value of a particular character. Now, let us see how we land up subtracting a number from a character. Have a look at this piece of code. I have a declaration statement called as char ch. So, ch is a variable of character data type. And I have an executable statement called as ch is equal to b minus 1. As usual, B is enclosed in the pair of opening and closing single quote, right? And then followed by two printf statements. Now let us look at what happens in this ch is equal to B minus 1. Since this B is enclosed in a pair of single opening and closing quote, right? Now what happens is you are trying to subtract minus 1 from this B. So the ASCII value will come into picture. Now, what's the ASCII value of small b? You all know the ASCII value of lowercase b is 98. So 98 minus 1 becomes 97, and this 97 will be assigned to a variable called as ch, right? This 97 is assigned to a variable called as ch, and this printf will print the character of it, and this printf will print the ASCII value of it, right? Now, coming back to this particular executable statement, I said that ch will get the value as 97, right? Now, the character whose ASCII equivalent is 97, right, is nothing but small a, right? Small a or lowercase a, that particular character has got ASCII value as 97, and hence the first printf will print character is equal to a, and the ASCII value, as I've already told you, it is nothing but 97, and that is the prime reason we'll end up getting the output as character is equal to a and ASCII value equal to 97. Now, the way we have done the job of subtraction, we can also perform addition, adding a number from a character. Have a look at this particular code. I have an initialization statement called as int I is equal to 20. That means the value of variable I is 20. And then the next executable statement, I'm trying to perform the arithmetic operation addition here. And I say I is equal to I plus A, where A is enclosed in a pair of opening and closing single quote, right? Now let us see what this particular printf will print and how it lands up printing that particular value. Now capital A, you know that is its ASCII value is 65. and the value of this I is 20. So the addition takes place, which is nothing but addition of 20 and 65. So 20 plus 65 becomes 85, and that 85 is assigned to the left hand side variable I, and hence the printf statement will print value equal to 85. Now this is how basically the addition and subtraction takes place with respect to character data type. Now let us move forward and focus on one of the most important subtopic of this particular module called as strings, which is nothing but string handling functions. There are lots of string handling functions which are available in C, and these handling functions are prototyped in string.h header file. That means it becomes mandatory for the C programmer to use this header file string.h at the beginning of the program, right? Before you make use of any of the string library or string handling functions. Now let us look into a couple of string handling functions, even though C supports quite good number of them, right? We also call it as string manipulation functions. Now, whenever we discuss string handling or string manipulation functions, right, the most important library function that actually comes in mind, or the first library function that comes in mind, is what is called as strlen. Now, this particular library function actually finds the length of the string, strlen, length, right? Now, this library function takes one parameter, which is nothing but the string itself, right? Now, there are two ways of giving this particular parameter. If you are directly giving the string, then you have to enclose it in a pair of opening and closing double quotes, which is there in front of you. I have enclosed GAT in the pair of opening and closing double quotes. So that is one way of giving the parameter to this library function. The another way of giving the parameter is through the form of character array, right? We'll discuss this after a couple of minutes. Let us look at this version of the parameter. So I have a is equal to strlen bracket open double quotes gat double quotes close bracket close semicolon, and immediately I have a printf statement which will print the value of a. Now strlen, even though I said it finds length of the string, please understand that strlen will not consider the null character. We have seen earlier in the introductory part that at the end of every string, null character is inserted. But library function strlen in its execution will not consider the null character to find the length. And hence, in this case, only three characters are considered, which is nothing but G, A, T. And hence, the value of A will be printed as 3. Now, if this is the case, the probable doubt that comes in your mind is, if string length is not going to consider the null character, how does the memory map look like? As a matter of fact, there is not going to be any change in the memory map. The memory map will be like this only. See, I have strlen of GAT, and I draw the memory map for GAT, GAT, right? So the address starts at 101, I have 102, 103, and I have GAT. And as I told, string will always be terminated by the null character, so I have /0 here. Okay, so strlen will count the characters that is given by the programmer, and it will not consider the null character. Now let us come back to our PPT, and this is what we have seen. Now let us make an attempt to find or to write a program to find the length of the string. Now I'm going to give you two versions of this program, two versions of this problem statement. One, you find length of the string with the help of a library function, and another one, you find length of the string without the library function, right? Now let us look at the simple version of finding the length of the string. So I have, as usual, I have a header file called as hash include string.h. I have a declaration statement where str is an array whose dimension is 20. I have an ordinary integer variable called as len. So these two things I don't need to explain you. I am trying to enter a string, and whatever I enter will be stored in a character array called as str. And then I find the length of the string using strlen. Now see here, you look at carefully, you have strlen bracket open, str bracket close, right? Now, in the previous example, I had enclosed GAT in a pair of opening and closing double quotes, but here str is not in double quotes, and that's the difference, right? What is it? If you enclose something in a pair of opening and closing double quotes, then that itself becomes a string. In the previous case, GAT itself was a string. But here, since I'm not making use of opening and closing double quotes, right? This str is nothing but a character array. And you agree, you have a declaration statement already at the top which says that str is a character array whose dimension is 20, right? So whatever you enter in the through the form of scanf will be stored in str, and this strlen will count the number of characters stored in character array str, and it will assign to a variable called as len, and the next printf will print the length of that particular string. Now let us look at a sample output of this. Suppose I compile this program and run, and assuming that I do not get any compilation error, now this is how my sample output looks like. It says enter a string, and I'll end up entering computer, computer, right? Now what's the length of this particular string? Keep in mind, you're not going to count the null character. So the length of the string is nothing but 8. Now what I want to tell you through this is this word or string computer is actually stored in your character array called as str. This one, character array called as str, right? So since I'm making use of character array, I need not run the program every time for computer. I can have any string, and then the program will give me the corresponding length of that particular string. So this is how you land up writing a program to find length of the string with the help of library function. Now let us look at another version of it where you land up finding the length of the string, but this time you are not going to make use of library function, right? So just have a look at this particular program. Now this is what it is, right? Let me copy this program to the Microsoft Word, and then I will explain you over there. Okay, so let us not bother about this memory map which we discussed earlier. Now just have a look at this, right? I'll just have a small change here. I'll have this declaration statement as int. Now, I have two declaration statements. This is a character array of str which has got dimension as 20. I have int len equal to 0, and I have another variable called as I, right? So len is initialized to 0. So whatever I enter will be stored in a variable called as str, right? Now let us say I enter computer. This is what I enter, right? So my character array str is nothing but computer. This only for your reference, right? Now it comes to the for loop, right? So str is holding computer because of this statement. Now it comes to the for loop. Okay, now what does the for loop says? It says for I is equal to 0, right? Now let me draw the memory map for this to understand how this actually works. So let us say instead of computer, I'll end up giving GAT itself. That's fine, right? Because I already have a memory map. I don't need to waste time on that. So for I is equal to 0, right? So the initial value of I is 0. Okay. Now I is equal to 0, and then str of I. That is what? Str of 0. What is str of 0? This one. Str of 0 is nothing but capital G. Now look at this statement. Str of 0, which is capital G, is not equal to null. That is true, right? So condition is true. The test condition of the for loop is true. So the control will go inside and it will execute len plus plus. Now what's the value of len actually, right? Len, which was 0, right? Now it becomes 1, right? And then since this is the only statement that is executed in the body of the for loop, the control will go to I plus plus, and I plus plus now becomes 1. And then the control will come back to this one again, right? It will come back to str of I. Now str of I is str of 1. Str of 1 is capital A, right? Now this A is not equal to 0, so the control will go inside. len plus plus will make the value of len as 2, and then I plus plus will increment the value to 2, and then it will come back to str of I, where I is 2. So str of 2, which is nothing but capital T, right? T not equal to 0, condition is true, it will go inside, it will execute len plus plus, so it becomes 3. And then I plus plus will make the value of I as 3. Control will come back here. str of 3 is nothing but null. Look at your memory map. str of 3 is null. I'm talking about this one, right? So this null not equal to null. Condition is false. So the control will come out of the for loop. And once it comes out of the for loop, it will print this statement: length of string percentage s is percentage d. What is str? It is gat. So it will say length of string gat is percentage d, which is nothing but len. What's the value of len? That is 3, right? And hence it will say length of string gat is 3, right? What's the length of string gat? It is 3, right? So finally you land up getting the, if you run this particular program, you will get the sample output like this. So you have something called as enter a string, and then you land up entering gat here, okay? And then what happens is, the next, once you enter gat and you get you press the enter key, the output you get is length of string gat is 3, okay? So this is how you land up getting the output if the input is gat. Okay, so this is how the program is written to find the length of the string without making use of library functions.